Shake Table Lab by Kaitlin and Olivia. We started off the tower by carefully placing the first cross brace so that our building wouldn't be crooked. We installed a straw for a cross brace on the first story so that our building would have a strong base. Next, we made the main support for the second story so that it would support many sandbags. We put strong cross braces on the second story so that it would have more support during the test. Because it still needed fixing, we added more support to the second story. The first story was 18.5 centimeters. The second story was 21 centimeters. We tested our structure with 2 sandbags on the top and 2 sandbags on the bottom. The cross braces were a bit weak on the second story. They required more tape. Our strongest parts were the cross braces on the bottom level. The part where the 2 cross braces met was probably the least secure because we used little tape to reinforce it. We used string to make a barrier for the sandbags for extra support. We used tape all over the structure in places such as the cross brace connections and where the 2 stories met. If we had 5 extra straws, we would have used them to make normal straws longer.
Hi, I'm Olivia McCrary from KNO News. Today we're talking about straw buildings.
Olivia, how many sandbags did your building support?
Our building supports 7 sandbags, and on the 8th one, it collapsed.
Where did your building fail?
Our building failed at the right corner because it kind of wasn't supported enough there, so we didn't reinforce the straws. So we didn't put tape around the straws there, so it kind of just went outside and then it just collapsed.
If you were going to build it over, what would you change?
I believe that we would change the second half. I think that the second half wasn't strong enough to support as many sandbags. So if we could have, I think we should have evened out the support of the sandbags, and it would have been a lot smoother throughout, and we probably would have gotten more sandbags on there.
What did you learn about building an earthquake-proof building?
We learned that when you're building a building that would be sustainable during an earthquake, it would usually have to be very strong, and the base plate would have to be very connected to the ground, especially in real-life emergencies.
Thank you, Olivia.
Thank you.
Hi, I'm Kaitlin from KNO News, and today we're talking about earthquakes.
How many sandbags did your building support?
Our building supported 7 sandbags and collapsed on the 8th.
Where did your building fall?
It fell with the right corner because we used a straw that was kind of bent, and I remember it, but it was probably a bad choice. We should have used a fresher straw.
If you were going to build it over, what would you change?
I'd probably change the way we built the second story. It didn't really support a lot, and also the bottom story, there was a couple cross braces that were a little weak, so I'd probably change that.
What did you learn about building earthquake-proof building?
I learned that to make an earthquake-proof building, you really have to have like a strong base because that supports the most, and you shouldn't put that many sandbags on top because it makes it more vulnerable and like makes it fall. easier, so yeah.
What did you like about the building project lab?
I like that we got to create a building and just learn about how to make it earthquake-proof and learn how to make a strong, sturdy building and how to be safe in an earthquake too.
Thanks, Kaitlin.
Thank you.
Here are the waves that were picked up during our test. The blue waves were picked up when the tower bounced, and the green waves were for P waves, and the orange waves were for S waves. The P waves were the largest because the shaking of the tower was forward and backward.